Hello and welcome to Evening Rust. I'm edA-qa mort-ora-y and we're here to do Rust and to play games and to learn algorithms, but mainly just to play around with Rust on coding game. Glad to see you all again. I think I screwed up my window again. Oh no, it's actually in the right position. Good, got it today. Don't usually type, but we'll be okay. I'll just minimize this. I just finished a Clash of Code before. As you can see, I'm screaming no golf over there. And I actually finished second. And I think it's because this was a tough one. It was a high avarice. This one was it had to do with deviation. So my code is pretty extreme here. I just add up numbers, put them in a vector, add them up. And very straightforward, very basic code going through. It just took me a long time to type. That's why Swanee here was better than me. Swanee, he knows Ruby very well. He got his nice little pack structure very well. So he got this pretty well done. And so this is pretty good. Did a great job there. And the other guys I think took a bit longer. I mean, everybody seemed to follow it except the last guy. That's okay. No problem there. And let's just go do another one because that's how we start the show. We just do another one. No point in not being nervous. And then today we'll go off. I think I do a practice day. I'm not going to do a multiplayer. Something unfortunate happened. We never made it to Grandmaster. Oh, we can't show you it. I'll show you that afterwards. Right there's. So we have the Grandmaster, or not Grandmaster, we never made it to Master. We're like a few points shy. Oh, we got Jasper joining us in the Clash of Code, and I think he's using municipal golf. No golf. That Jasper guy, he loves golf. We'll see what we get. Honestly, I don't do so bad at golf, because if it's a hard problem, I'm good at golf. If it's a quick problem, I have a hard time typing Ruby or Rust fast enough. If it's reverse engineering, then we have an issue. And we'll see what it is. Can I say hey at people? Let's see. There you go. So we'll see what we do. Ion Codes is there too. So Ion Code, you're joining us as well. It's great. We'll see what happens here. Clash is starting. We want to oh no, not reverse mode. Test 466. Test. This is amazing. Test 467. Oh my, oh my, oh my. It has to do with the length, I bet. You drop one. It has to be an odd length, it looks like. And you just drop it on and off. And I have no idea how to do this in Rust. Oh my, this is going to be awful. I know exactly what the problem is. It seems fairly easy to do. And we can test the second case right away. If message.len mod 2 does not equal 1, or equal 1, then we return, we print line error. Let's confirm the second one at least. Yeah, we got the second one, so we got it confirmed. And then it's just a matter of printing the string over and over. And we're going to divide it by 2, I guess. So it's going to be like for I in 0.message.len divided by 2. And then we'll do it again the other way around. So we trim off 0, then 1, 2, 3, 4. Okay, I have no idea how to do this in Rust. So I think there's a repeat. So we do print line. I'm going to put the spaces in. Then we're going to put the text. And I guess we don't need any more spaces after that. It's hard to tell. I hope not. Then we're going to have a space dot repeat I. And then we're going to have the message. And we're going to try and use a slice here, though I honestly have no idea how these work. Message.len minus I minus 2 times I probably. And we're going to get all sorts of typing errors because it hates me. I mean, it just you know, never works out on me. And let's see if we can actually get the first bit done. And we have this first problem. We can't see anything. Size. Where is the error at? Str does not have a constant known size at compile time. That's exactly where it's beating me up already. Which one is the problem here? Come on, just can you tell me something about what the problem actually is? Well, I thought slicing this would work. I guess chars would do that as well, wouldn't it? Cannot index into. How do I do a slice? I just don't know how to do slices. That's my biggest problem. Why can't I slice a string? That's my shitty problem. I have to know how to slice a string, and I don't know how to do that. You can't? Well, why not? That's stupid. Why can't I slice the characters? That's why I said characters. That should work then. Cannot index. Oh, come on. This is kind of silly. Okay, I can't figure out the syntax here, so I'm just going to do it the bad way. For j in I dot message dot len minus 2 times I print message j as usize, I guess. So that's pretty bad, but I'm okay with that, and we'll have to do it again though if we got errors there. I thought you could index into a string, so you can't index into that either. Oh, wonderful. How do you index into a string? Shit, I don't know how to do it. Rust index into string. Bytes probably would have been better. How to index into a string. You gotta be kidding me. Whatever, this is okay, message.bytes. Can't index into that either. Come on. I just want to index into a string. It can't be that hard. Oh, come on. This is getting stupid. Rust string. It wasn't that hard of a problem. Message as bytes. Oh, let's do that. Okay. Let m equal message at dot as bytes. Yeah, that's what I wanted to do before. Exactly. So comment this out. That was the intent of what I wanted to do. Then you're saying m and mi dot yeah, message dot, or doesn't matter, m dot len minus I 2 times I, and that should have worked. As bytes, good enough. Cannot be formatted with default format. Oh, I can't format that. Let's see if this works. The debug one. Standard output. No, it doesn't. So we can't format it that way. Great. Standard dir from UTF-8. Come on. So a string can't be formatted either. Oh, that's the result. So I'm going to have to unwrap this. Okay, I'm going to have to do a print line here. This is a print line, and we're going to have to do it again. And this time we're going to do... Sorry, Iron Coach. I don't mean to laugh, but yeah, that's the buttons are right close to each other. I think we said you could do... No, you can't do reverse loops. We had this problem before, so we actually want to do not repeat I. We want it... let q equal message.len divided by 2 q minus I 2 times q minus I. We never did figure out how to do reverse loop. And slice bounce, but ends at 1. Wonderful. Shit, now I don't know what the problem is. Test expected, test for 6. Well, it's complaining about out of range, which is a problem because if it's expecting 4, 6 and we wrote 4, okay, well, I don't know what to do here now. We're starting at q minus I. It's correct. We want to actually, we're just reversing the loop. Minus 1. Minus 1. I forgot to do the minus 1. Okay, so we're missing 1. We have it doubled in the middle, so we have to skip 1 here. Found S4, decided S4, 6, so we're skipping off too much at the end. So we're cutting off too much. Why is that? Plus 1, I guess. I'm not sure why. I got some indexing wrong here, but we're going to index, so this can't be that. Okay, let's take that off, and let's do another plus 1. Wow, this is really bad. Shit, I got the indexes wrong somewhere. There's something wrong with the indexing. I don't quite see it, unless there's something there. So if we didn't have that plus 1, what do we get? And, okay, too late for that now. So this plus 1 is wrong. So what are we doing wrong? We're missing a character. It's too long here. Minus 2 times, maybe it's just minus I? Maybe I don't understand the iterators. Maybe that's not an offset. Maybe that's a length. Expected t, so we're missing 1. There we go. Yeah, so that's the one I get. So that's obviously not the case. I don't know what the air condition is. We got to figure out what the air condition is. Panic result, unwrap. How do they get an unwrap air there? I'm run out of time. So this is an air. I assume because the message length was too long. Let's try the last one. Last one's fine. So we just have this one, found error. So that program is apparently okay. Test my program is not an issue. It's probably because of this U here. We can't do UTF-8. We have to do characters somehow, because this U is going to be a problem. Because that's not a UTF sequence. But I'm doing message len. What if I just do mlen? And screw it. Is there like an as ASCII? I don't know what we're going to do, because I wanted a character editor to start with, but we have an issue there, and that U is going to really screw it up. There's really not much we can do about that U, unless we can quickly figure out how to actually do a character iterator, and I don't know how to do a character iterator in Rust. Anybody know how to do an actual character iterator? Like, is there an as chars? No, there isn't. So without a character iterator, we can't actually do this. How can we figure? I need a Rust character iterator. Rust char iterator. We do a collect. What if we do a let chars dot collect? No, we can't collect it as a string because it's the same problem. Collect vec char. Well, this, oh, we have syntax. Oh, you mean I can submit this without it? No, I'm doing something wrong. There's an error. It's the error in the validator. Well, fine. Let's submit it then. No, we got 75%. I think it's actually totally fair. I think it's a fair case, but it's a matter of Rust. I don't know how to do a character iterator. It's what I wanted to start with. I wanted an actual character iterator, and I should have been able to do it. But we didn't know how to do a character iterator, and so let's figure this out first. How do we do a character iterator in Rust? Implement from... no, that's not it. I guess we could do a vector of it. I can't test it again now, so... Oh, well. So all these other ones probably just have character iterators. Yeah, this is iterating by characters, so Ruby actually fixed that. This might also be doing characters. Oh well, whatever. We know why we failed, so I'm not so concerned because it's a... Jasper probably also had the problem in JavaScript. Yeah, JavaScript has Jasper complained. UTF-8 is shit. That's correct in JavaScript. And on Rust, we don't know because we just don't know how to get a character iterator. And Iron Codes just press submit instead of test. So yeah, that's it for that. Where did we finish up? We finished 5 of 8. We have a bunch of other ones I did today. I wasn't so satisfied with that one. I want to do one more before we move on because I really love to know character iterator. How to convert... No. Rust character iterator. Or Rust iterate chars in string. How do we do that? Iterate over string by character. Chars. Chars.enumerate. Well, we have that. So chars should have worked. No, but we want to do a slice. Must be a Rust substring. Maybe we put it on a substring. How do you get a substring of Rust? That's the one we want. Strings can be sliced. I actually get really confused in Rust by this because we have all these examples online and half of them never seem to work. And this is not a string type, it's like a stir type or a slice type. And so I'm actually getting really confused by this. And I still don't actually know what can be sliced and what can't. It seems to just vary on me randomly. Just whatever one I want, it seems to just ignore me and take the other one. And yeah, so you can't... And I kind of find it an error. Why can't I take the index of a string? It's clear I want the character index. Let's just treat it as an array of characters. I guess maybe I can do that. Characters.collect. That would work. And then I could take a slice. I don't know. I would have to try that. If we actually knew how to do that, I'm pretty sure we could have run that contest because that wasn't that hard. We basically had it. The Christmas tree one is basically the same without the string. Let's see, we have some new people. I just wanted to do one more, and then we'll move on to the practice. I think I want to do Labyrinth today, get some graphics. It's a bit of pathfinding. I think it'll help for anybody else watching, wondering what on earth we were doing in the Tron thing. We can see some of the code there and how the Tron stuff works, because it will be basically doing the same algorithms. With my luck, I'm going to get golf here now, and that's okay. We can deal with golf. I guess Ion Codes and Jasper probably went off and did that one that pressed start. But I'm going to just do one more, and should be enough. We have to learn. I should put that on my list of things to do. How to iterate over a string, because if we do these contests, it's something that comes up a lot. So let me start my Visual Studio. Do I have my cheat sheet? I have a list of to-do at the bottom, which is, oh fine, I started installing that one thing yesterday. It's probably going to annoy me every single time now. Slice a string. I'd really love to know how to do that. Difference between stir, string, etc. I have to learn that. I don't know what that is. I'm going to pay close attention to that for Leaf, because in Leaf I don't have a string type yet. I just have an array of characters. And technically that's all I have. I don't know if you really need a string for the base language. An array of characters, it's a proper array of characters like Unicode characters, and that is all the basic operations. and I'm not trimming it as text. It's not actually text, it's just a string of characters, and you work with it as a string of characters. And if you'll create a high-level library, I'll create an actual Unicode library which can deal with it, and then maybe introduce the text type. But in programming, I seem to be in favor now that there's a very strong distinction between what's a short character array and what is text. And maybe we shouldn't have something called string, because it's confusing, because people use it for various purposes. And it may not always be the same. I don't know yet, though. It's one of those areas I'll have to work on. Alright, so we got a bunch of new names here. Swanee's been here for a while, for the last hour, I think. Played one of them before. We have Marianne, Furbos, Liuting, Jules, and Chase. And if we get one more, we'll start. Otherwise, we won't. I like all 8. 8's good. And I still don't know how scoring works in Clash of Code. Whether we have to win, or we just get points, or I just don't know. I don't know how the points are worded in this. We keep climbing up the ladder. Regardless of what my results are, we seem to keep climbing up the ladder. I suppose once we get high enough, we're actually going to have to win some of these to get any higher than that. Oh, we got Lynx again, or Lynxy. What do we got? Just no golf. No golf. Come on. Another reverse mode. Oh, I hate reverse mode, to be honest. A is greater than B, A is greater than C. I guess it's going to be the highest one. A is greater than B, A is greater than C. A is greater than B, A is greater than C, E is less than C. Well, crap. This is, well, where does this come from? B, C, Z. So it's all the ones, wow. I think I know what it is. You take all the lowest value items and output them in alphabetical order. And Jules, I don't know what you did that you have an answer, or you haven't even thought about. I'm not even sure how I do this in here. Or these are the highest value ones. Okay, so there's 5, and I think I have an idea. If there's anything greater than it, I think I see it. I think I see an easier solution. Let ends equal vec new. I'm going to make this a vec of, I think, char, or whatever this is, char. And it's going to make it really annoying. What I need to do is I need to say let line.chars and 0 let b equal line.chars and 1 let c equal line. I'm sure there's some sort of padding margin for this. If b equals greater than ns dot push a, else ns.pushb. Now the trouble I'm going to have here is going to be a real problem that we have a set. We really need a set here. I don't know how quite do a set yet, or we can put a set. But let's just see if this works. First of all, we're going to do for I in ns, and we're going to do a print. I hope it doesn't mind extra spaces, and this is going to be an I plus. Actually, that should be fine. We don't need that. It's already a character. I should have left that there because I need the print line. And now we have errors. We did mean print. Is that the only error? It's just tiny here. Alright, we're going to assume this. We're going to unwrap all of these. We don't use C. Well, yeah, that's good. That was actually a good warning. We don't use C, which is borrow ROM again. And we're not sure. Okay, let mut. Going pretty slow here. I'm okay with that. Found A expected nothing. Well, that's not very nice. The hell? How on earth would we expect to have nothing in here? That's just not very nice at all. So I guess something screwed up here. A print line. A, B, C. So something's wrong there. A is greater than B. A is greater than C. So we found AA expected nothing. Well, that's kind of unfortunate that we've expected nothing. We expect only A. Let's just do a hash set. I think there's a hash set. I don't remember how it is, though. Use standard collections hash set. Add, and we can do a contains here after, so we only add them once. Insert, come on. Why did we expect nothing? That's stupid. So we have A is greater than B, A is greater than C, and the test case expects nothing. I don't understand. Expected A, we found F. Okay, obviously I don't know what they're wanting us to do here. My assumption that you just take the highest valued ones is not going to work. I'm going to say if... What if it only expects that one? Does it expect? Oh, that's sad. Expects nothing because the extra space is a problem. Okay, so let mut first equal true. If not first, print space. First equals false. Found C dot 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 expected A. Okay, I don't know what they want. Based on these test cases, all they've done here is they said if it exists on the left side of a greater than, you write it out. C A, but they put a C here. They put it in order though. Yeah, we're going to have to order them. I don't know how to order them that fast. So we actually have to find the ones on the top. I'm not going to be able to do this fast enough. Let's see what we can get done here. Is there a quick way to do this? A is greater than B, A is greater than C. I don't know how to do ordering in Rust. That's like a little map. Not going to do well here. Look at the last one here. We actually corrected the last one. We just have the wrong order. Anybody know how to sort? Let V's equal ns dot. How can we do that? Well, let's just do this. Let's do it the hard way. There's got to be a way to collect these as a vector. Vector C, vector char. At least we can solve one more of them. I think we know what we have to do. It's just a matter of q.sort. And that would at least solve this one, if we got it right. Cannot borrow q is immutable, yeah. Why don't they just have a var? It's let mut's annoying. So we got at least two of them, maybe no output. And I know exactly what's wrong. This is really an ordering thing, but I actually don't know how to do graphs that quickly. Hello LKFS, we're just about to lose badly on a clash of code. Everybody else is done, but we'll probably still be somewhere. The issue is that we have to order these values, and I actually don't know how to do this. In general I would be able to do it, but in Rust in 6 minutes don't think I have a chance. Is there a simple solution I could do? It is kind of a weird ordering. A is greater than B, C is greater than C. I'm trying to order these things to come up with the total ordering of these values. So if A is greater than B, C is greater than B, and A is greater than C, the top value is A. And what I've done so far is just quickly, if it's on the left side of a greater than, we bring it up there. But obviously that's not enough. I'm just trying to think of a quick way we can actually do this better. How could I actually do it? Well, let's do an alternate one. Let C's, we'll put count, and this will be a vector int. And we're going to make it a vec 0 of n as usize. No, sort by is not the issue. I have the sort by in the end. Yeah, but this whole thing is the ordering, isn't it? Oh, that's right. We could actually do the whole thing in a closure and just take this whole thing as the condition. All of these things added to a condition table and for any two values, but it's not complete. So I don't know if we'd be able to do it. Let me just check another one here. And so let's just do this. CS. I'm going to just temp it here. A as this is usize. A as usize minus A as usize plus plus. I'm just trying another quick cheat. This might get us far enough across. Anytime there's a greater than, we put a plus plus on it, and we just take the highest ones, and it's going to be C as usize minus minus, A as usize minus minus. Do those even exist? Minus minus? No. I'm running out of time. I can't read this error output here. As usize, expected what? I got the vec in the wrong way. Okay, so we can't, those don't exist. 1 plus equals 1. Ah, crap. Overflow, no, piss off. What do you mean? No, n. C is usize minus A is usize. That can't be out of bounds. The len is 2. We'll just screw this. I don't know what it is. And we need a value here. If CS I as usize minus A as usize is greater than 0, then we push it. Only in that case we push it. That's what I'm hoping works. It's a really quick, cheap. Okay, that gets us by it. Oh no, 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 no! Except the index out of bounds because of Z. Shit, it's because of the Z thing. So, screw this. Let's just put this up to 30 and that'll cover Z as well. This is a really awful solution, but if this works, it's okay. It's cheap. I'm not actually doing a total ordering, I think. So I don't think I'm doing a total ordering. What I did is for every greater than, okay, so it fails in one of these, and that would actually make sense because I didn't do a proper ordering. I just did a really cheap plus and minus. But that means the test case relevancy was bad because one of the tests didn't actually cover the resulting output. So technically, I could have reverse engineered what they gave us, right? But logically, I didn't. That is, if you gave this input to a machine learning algorithm, it could come out with something what I have, which solves the test input, but then doesn't actually solve the real input. And so technically, this is a bad relevancy. And the difficulty is, well, it's hard for me in Rust, and that was okay. So we still did okay with this. I mean, the harder they are, the better we tend to do. And it's a hard question to solve in this time. I mean, total ordering without knowing the library. And I guess the Ruby guy, he's been very good. I bet it's very short code. And he does something very similar, though. Okay, so he's also not doing a total ordering. And ends up with a decent result. So maybe my cheap solution just wasn't the right cheap solution. Maybe we have to find a different cheap solution. Or maybe he's getting closer to the ordering. So we screwed that up. I can share my code. I don't care. It's broken. This is very similar, obviously. These guys solve it so fast. I mean, I think they sit around doing a lot of them, and that's very good. It's really cool that they can do them that fast. We're nowhere close to that. But we're still going to be doing okay. The clash is complete. We should get a score here. But I wanted to show you this over at our score from yesterday. We did all that golfing, and it didn't help. We're still stuck here, just below the master level, because the code golf things we did, 189, okay. What did we end up with? Which one was the last one we did? We got less than, or 189 is pretty good. I'm going to check what we did. What did we do? That was the compete. So yes, we are third, even though we did poorly. Which golfing one? Oh, that was the, huh? Do you mean the clash of code or the actual golf code, like don't panic? Temperatures. What score did we end up having anyways? Go down to the... We had 238. You got 189. Wow. That's nice. That's nice. 189. Let me see what we did. Can I see my code? Oops. You guys disappeared on me. Can I see my code still? Let's look back at my code. Oh, I can't see it because it's awful now. But I want to see what you did. You did a... also did a split white space. You read the whole thing into a string. And you did this mapping, min by key times... What on earth is this times 4? Did you just... Why is there a times 4 in here? That's pretty cool. I hope you... Did you submit it? Do you mind if we submit it? Can I submit this over and we'll get points for it? Okay, I can copy and paste? I want to see it work at least. So this actually works. That's cool. But what does the times 4 actually do? Why is there a times 4 there? Did you just take like the maximum number and make times 4 work? Yeah, I got that. All the blanks have to go away. Yeah, you squared, I get that. Squaring is, that simplifies it. I think I have an idea. Okay. Yeah, okay. Got it. That's cool. That's pretty cool. That's very clever. That's a nice mathematical solution to that. So 189, that's pretty cool. Maybe just a few more points. We probably don't move up in the ladder much. It probably moves us to like 6-2 something. And this is, we'll call this our show. This is LKSS solution. Or is it an L or an I? I can't tell in the font. So let's check the leaderboard. Let's see what Rust has. And where are we? Come on, push it up. That puts us pretty high up there. Puts us right beside this guy. IKFS. Puts us right beside IKFS. I wonder if you get to go in front of us, or what order we keep. Oh, that's not fair. That's not fair. I'm sorry. There's no reason we should be in front of you. You should have. I have a lower letter of the alphabet, so I mean that just gives us a better score, I guess. That's pretty cool. Thanks a lot for that. That's really good. I liked that trick. That's a nice little trick. The min by key is kind of cool. Min by key, and that computes the key value. So you get the action. This was the trick. This function. I like this function. Euler-Schitzal said once that some of these guys could be cheating. There's two options for cheating. We don't know. The one is you could be calling a system command, or the other one is you could just be like loading from a server somewhere doing a dynamic eval, but with Rust that might be hard, but these might be system commands. I'd really like to see one to know what it is. Though this P. Marcel guy right here, at 10 characters less, this looks like it could still be legitimate. We just don't know what it is he did. And yeah, we just don't know. It could be a legitimate one. We'll see. And all right, but today I actually didn't want to do golf, so we got that golf. We're a bit better there. I want to go off and do one of the practice ones. I want to do the Labyrinth because it keeps showing it to me. You can remove I6. You gonna make me go back to there again? All right, we're gonna do that again. And Quinn has another idea. And we're over here. You can't. He tried. He tried. I'm gonna try it anyways. Well, apparently you can. What about that? Gets us a bit further. Group effort. Maybe it's a different Rust version. Maybe there's something that changed. And we're still not at P. Marcel. He still has 3 characters left. Ouch. So you gotta get rid of 3 characters from there still. If anybody wants to, they can. Actually, where did you put that code again? I copied it. I scrolled that window down. You don't need this. You could just do this, because you only use it once. Let's try that. I think. Or do you use one of the traits? Let's find out. I'm tempted. I'm tempted to get rid of that now. Okay. Read to strats correct. Yep. That's why we needed it last time too. Okay. Let's not dwell on it. That's great. And there might be Rust versions difference. We're got a good score there. Great score. And you found a better solution for it, so that's wonderful. But let's move on to the Labyrinth. This one looks like Pathfinding. This is going to take a little bit of effort to go through. And we have grid code all over the place. We know we have grid code. And we're going to create a new file for this. Not here. I'm going to go and do it in Visual Studio. Oh, it's already running. Here we go. I keep you guys back on top. You keep disappearing. Okay. Copy Thor.getIgnore to .cat.getIgnore. Let's just make this global now. Slash. No. Is that enough to ignore them? Well, that's not nice. Alright, in any case, let's do a cargo new, what's a Labyrinth? It's a bin. And we'll put this back on VCS as git just to get that file. We're just going to remove the .git directory though, because we don't actually want that. We just want the getIgnore. And we're going to download this. I got to start my, see whatever I have on my desktop. I don't know why I put it in the corner. It's really not necessary. It did until we shut it off. We put VCS none once, and it appears to store that somewhere because every time I ran the command again, it never created git again. And all I want is the getIgnore, and because I don't want to create a new repository each time, I just want to create a new directory. Okay, we're going to select a file /source/coding game. Select main, we're going to download the ID of the file. That's good enough. We're there, we're good. And this is absolutely nothing, so we don't have it here. We can make this bigger. Let's play it to see how badly our guy does. He's going to just stand around doing nothing, I guess. Kirk just goes around and hits a wall. I guess he moves some direction. No, he's just going right here. So what we have to do is we're going to have to create a grid. I think I have the general idea. We have the fog of war. And how does this read in, though? I got to read the input format. He go left, right. Kirk is doing a trigram scan around to do structural. He was only able to scan the cells located in a 5-cell wide area centered on him. There's a trap. Once you reach the control room, an alarm countdown is triggered, and you have only a limited number of rounds before the alarm goes off. Once the alarm goes off, Kirk is doomed. Kirk will die if any of the following happens. Kirk's jetpack runs out of fuel. You have enough fuel for 1,200 movements. That should be enough. Kirk does not reach the starting position before the alarm goes off. The alarm countdown is triggered once the control room has been reached. Kirk touches a wall or the ground. He's ripped apart by a mechanical trap. That doesn't seem like a safe ship. You'll be successful if you reach the control room and get back to the starting position before the alarm goes off. A maze and ASCII format is provided as input. The character blah is in a wall. The letter dot is a space. The T represents your starting position. The C represents the control room. And the character question represents a cell that you have not yet scanned. Okay. What do we get each round? Number of rows and columns in the maze, fine. Is the number of rounds between the time the alarm countdown is activated and the time the alarm goes off. This is completely irrelevant because we're optimizing it. I don't think we need this. I mean, we're just going to optimize the way out anyways. There can't be anything better. Integers K and R. K is located now at KR and KC within the maze. The cell at 0 and column 0 is located in top left. Next line, C characters. Next R lines. So this is doing the, it's just showing the grid every time again? Okay, so it exposes it. They could have made this harder. They should have not exposed it. They should have just, each time, they shouldn't have actually exposed the code of war, or the fog of war. They should have just kept it so you have to keep tracking your own. We're going to keep tracking our own anyways. And what we're going to do is we're going to find out, it says take as long as we want, but we have 1,200 moves. So what we're going to do is we're going to have to move around just looking for the closest one. This is going to be the same type of algorithm we had in Tron. Wherever we are now, I think we just find the path to the closest question mark, and we just head towards it. And that means we just have to... And then once we found all the question marks, then we just go to the exit, and that's a simple, I'm going to say something, that's an A-star algorithm, which again is very similar to flood fill. And once we get there, we just do a an A star back to the beginning, to the starting position, I think, right? We have to get back to the starting position. So the initial input is given as a T. So we're always in T. We're at T and Kirk has gone one to the right. Okay, so now we're going to need to go back into that code. Now we get the yummy, funny code part of it. Close this. Nope, I don't know what that is, so let's close it. And we'll open it up. And this will be a bit of coding, first of all. We don't have... These aren't simple enough anymore. Yeah, so Memoriam, I'm guessing what it did is I set it once and it turned it off. But I kind of want like the half setting. I wanted to create the git ignore, but not create the git repository. It's a little bit weird. I can just delete the thing every time if I want. It's not terrible. Source, main. And we're going to open up another one. We're going to start with the code from Tron. Which we just did as a big file here. We didn't even have the cargo set up yet. We didn't do a lot of local testing, which is really weird. And there's a matrix file in here, so there's a matrix thing in here somewhere. Well, I'm putting these all into one big Git repo. I don't want each directory in its own repository. That gets a little bit hard to manage. And the git ignore is relative to that directory, so I'm actually just going to stick them all into one repo. If I ever publish it. I have it private right now. I'm not sure I'm supposed to publish these things because they're answers to their questions. I don't know. I haven't decided that yet. Okay, so we have a matrix. I'm going to copy this off. This was a decent matrix class. I'm going to take a board matrix again. We can copy a lot of this stuff. See, we have point 2 is also here, point 2, step. This is all the same thing, point 2, any negative state we don't have. So we're going to take a lot of the stuff we had before and reuse it. We don't need the print error at all. So we have this matrix. It has a vel vector, and we're just going to make the board eyes again. Maybe we should use an enum this time. Let's actually do an enum. Create alias cargo. Okay. Yeah, Crossbow, I can do that, but when I create too many aliases for small things, I just end up forgetting what the alias actually does. Cell type. We're going to have a bunch of cell types. And what are the cell types the game has? I'm going to say unknown. It has a wall. It is empty. It is the start. It is the control center. And start control. Is that all we have? Wall, empty, unknown, control center. I think that's all we have. Where is that written? Where is it written? Wall, space, start, control, and unknown. Perfect. And we have to make a function that is empty or is open that takes a cell type. So I don't know if you can you put traits on enums? Because that's what I'd really like to do. I'd really like to put this on the enum. I don't know if anybody can do that, so if we had, that would be helpful. It doesn't make a big difference, and we're just going to return, we're going to say ct equals cell type.empty. Good. I'm told you can, so let's do implement cell type. And self. Actually, this has got to be a copy type, so we don't even need to do the and. I don't know if it's better. We're going to just do a copy type derive copy debug. And a clone. We'll do a clone as well. These are good. So it's self type. We probably don't even need the, if there's a copy Probably don't need that. I don't know what the general thing, best practice is. Do we put and here if it's a copy type or not? I don't know. Self equals copy type, empty or self equals cell type dot. Wait, we're inside cell type, so I should be able to do this. We're already inside there, equals start, or self equals control. Though, you know what? The moment we touch control, the alarm goes off, so I don't think the control qualifies as an open space. So those are our open spaces. And our board matrix is going to be of cell type. Okay. Reduce that. We have the matrix, we have the push, we have the fill. Do we have a clear on here? We'll do fill. We're going to find that main function here first and start reading the stuff in. So we have this ugly main function here. Don't want that semi. Now I scrolled all around. No, I didn't want a semicolon there. Absolutely not. You're correct. I know what you meant. Don't want that. So we have the main. I'm going to start reading. We're not going to be able to test too much locally. The very basic ones maybe because of scanning, but let's put a state in here. And we have the board, which is a board matrix. And we have the position, which is a 0.2. This is our current position. So we really need to, and with state should probably also have the start position. And the control position once we know it. So what this is going to have to be an option of 0.2 because we do not know it yet. Get rid of that, collect the number of rows, number of columns, and that should also probably go in the state. And we'll create the state this way. Function new, and it's going to take the number of rows and columns. I don't know why those are I32, but we're going to keep. Yeah, okay. Alright. Thanks for being here, IKF says. Have fun in Counter-Strike. Good luck there as well. We'll say X I32, Y I32. This is all we need to do to create the board. We just don't need to track A. I'm always wondering about values like A. Why do they even have them? I just don't know why they need to be there. And so we're going to create a state. These we're going to do a derive. Did I actually get this right? Default. So they can all be a default. Our 0.2 is also going to have a default. So we don't have to keep duplicating this stuff. So S equals default. This returns a state. So the final value is S. And S dot board equals board matrix new. How do I do this? XY. And we're just going to fill it right away. Fill, what do I call fill? Fill is, yeah, just the type we want. I still haven't set up using multiple files, so we got to keep going up and down. It's a bit unfortunate. Fill, and we want to do cell type dot. Actually, it really doesn't matter here. They're unknown. They're all unknown to start with. It's going to tell us every single round anyways what they are. Okay, and the start point should never change. So the game loop, we read the line, and ours, each row, we read the line. And so for C in row, and we start with X. So this is actually Y. This is our Y position. Let mut X equals 0, I32. And then we can say, we need a state somewhere here, so state, mut state equal, what is it? State new rows, comma, columns. Okay. State.board.set. They have the point 2. Set point 2, value. There's no way to do overloads, unfortunately. So I can't just put x and y directly. I have to actually always put them in the point 2. And we'll do a match on this. Match C. I hate that auto indent. I don't know how to get rid of it either. This is a wall. Dot. This is a cell type.empty. And T is cell type dot. You know, let's screw it. Let's just say these are empty. Simplify the cell types. Let's get rid of start and control. Then we don't even need this is open. We just have empty. And we'll just do it down here. If we get a starting point, we'll just do this. We'll say state dot board. No, state dot, what do we have? Start. State dot start equals 0.2 x comma y. And it's still also just empty. We don't care that it's not empty. Then if we have a C, we can do the same thing. State dot control equals some 0.2 x comma y. It's also just considered empty. Or no, that's why we didn't want to consider it empty. Undecided now what I do in that, because we're gonna have it. Well, let's just consider it a wall for now. We'll just override in the end when it's a wall. Then we just go there. We actually just absolutely want to go there. We'll get the closest one and then just step onto the control point. Everything else is going to have to be unknown. We don't even have to know it. Cell type that unknown. That's our big fog of war. And that closes that off there. Okay. So that should be our board. And let's just write a dump function for this first. I'm going to start putting this all on the level here, and state, impl state. Let's put a function dump. Don't need that. That's leaf format. For y in board dot, what do I call it? Board dot height. For x in board dot width. Let's see our position. If position dot x or 0 equals x and position dot 1, this needs to be a self and self. So if we're in this position, that overrides it. We're automatically in the space. Then we emit that. So we're going to do a print a character. I wish there was a way to actually emit a character. Then we'll emit a T. No, that's not the starting point, though. We'll just say where we're at. We're at there. Else. Alright, I actually don't like combining these. I'm just going to actually, well, fine. Else match. What do we have? Board.get 0.2 x comma y. And what do we have? We have cell type that unknown becomes unknown. Cell type dot wall becomes a wall. Cell type dot empty becomes a dot. And I just want to redo these debugs so we know we're parsing it correctly. So this dump dumps everything out. And we're going to have to print a line at the end. So we're going to dump it here, state.dump. And let's see if that gets us far enough. We're just going to compile it here. Cargo check. Check is the one not building. I remember that. Okay, so we have errors here. And where are we at? Okay. Oh, we didn't have many errors. I was assuming a whole bunch of them. Expected one of at if. That's in line 132. Oh, else match. Oh, this is returning this, else match that. It's probably, is it unknown? I can't remember this. 172, wrong place. 172, so we got something screwed up here. We're missing the end of the match, that makes sense. 166. That's fine, it's fine, it's fine. 133. Alright, so these are supposed to be colon colon. Colon colon, alright, here we go. Check. Lots of errors, that's good. All sorts of errors. I'm going to do a clear and check. Clear that out. Did you mean X at 121? I have no idea. Let mut-s equal default. Not found in the scope. It's strange I had the pipe state there, but I'll live with that. 128, G128. This is actually one of the things that bugged me a lot about Python, is you have to have this self everywhere. I don't like having to type self. I like the idea of scoping and variables coming in automatically. It simplifies the code, and I don't know, I prefer it a lot because this is just redundant. We know we're in here. We already have scoping rules so it's not like it's totally foreign here. Okay, what else do we have from cell type.wall 167? Alright, all these are the wrong ones as well. I don't know why Rust adopted C++ style for the static access. It's the one thing I kind of like from C# is that you just put a dot everywhere, and I've done the same thing with Leaf. Just put a dot. If it's a static field, it works. If it's a type, it works. And I think it's because in Leaf what I've done is cell type, even though it would be a type, it's actually a variable as well, so the dot makes sense. The type itself is an instance of a type. It sounds really weird, you don't have to understand it while coding it, but it works out well. Default is not implemented for board matrix. Oh. That's probably why we never did that. Probably why we never did a default for state as well. So now we just do this way then. Board is position is 0.2 default. She really makes no difference. Start is 0.2. And 0, is actually, that's just do default. Makes sense. I think it's clear what we want. We don't really care what this is. Control is none. Oh yeah, we had to do this. Let mut-s because we have to fill it. This is a board actually. Board.fill. Always says first code takes forever. I32 is not an iterator. E142. Well, that's interesting. Where does it think I'm trying to iterate I? Ah, right there. Getting there, getting there. 169, 169. Expected I32. This doesn't need to be a... This does not need to be a use size there. Variables not need to be mutable. Let's get rid of these things. I don't like these unused ones. This actually makes it really hard to reuse code. I just lost... There's probably legitimate warnings in here, but this is getting just really like, ugh, lots of stuff in there. Let's see how we do in the first round. We're going to output something. And what do we get? We output nothing. What did I do wrong? Oh, I know what I did wrong. Our dump has to be an ePrint, so it doesn't assume that we're actually trying to do an output. So we can see what we get. Now you can stop now. So something seems wrong here. We must have parsed it wrong already. X, Y, this is probably correct here. And we've not actually parsed anything in yet. For C and row.chars, it's because we never implement X. We do Y, but if we're in the middle, that would make sense. So X plus equals 1. And so these are probably all fog of war anyways, and that's why we never found it. Alright, so you notice it does reveal it, and what am I outputting W for? What on earth is W? Wall. This is supposed to be a wall. And I think we have this here. If we don't have the starting point yet, I'm going to actually do that as well. The starting point is also optional, because when we do it down here, state.start, I'm going to do this. Is state.start. So only if there's nothing there to do we update anything. If it ever changes, well, that's not my problem. I'm going to return this at the end. And the reason I do this is because our state position becomes the starting point. So the first time we do it, that becomes our starting point. So Kirk has to go right to our starting point. And I should have compiled over here. Alright, so that makes that actually easier too. This starts as none as well. We don't have to care which start is, and alright, 174, some, actually let's do it this way. Some state.position, then we do this. Alright, where are we now? Do we actually show something in the output? Alright, so at least we show the @. And we haven't actually accounted for our moving yet. And these are all walls, which is really interesting. How can they all be walls? That's a bit weird. That's actually really weird. T is never going to move. T's there, and C is that. And otherwise it becomes unknown. I don't know why there's so many walls here, though. I don't want to start. Let's check a second level just to see if it's something with my parsing that's wrong. We have nothing. That's odd. So we have something wrong here. Y and 0.r. Oh, we can update the state here. So let's undo the start being a option, because I don't think we need it. State position. Because I didn't realize we output the position of Kirk every single time. And I noticed that we have the wrong indentation. And so state.position equals 0.2 kr, kc, so Kirk actually moves around. And that's fine. We input that. Okay, and Koei, that's what I thought, but we don't see this control room. Oh, that's because I'm an idiot, because I have it right here. Because I kept putting wall for it. Oh no, we had to put the control position. Ah, no, my output's wrong. That's why. Ah, no, I simplified it. I know exactly what's the problem now. Yeah, first one is a straight line. Imagine that. And so we're going to have the same thing here. Elf. Actually, this is getting too yucky here. So what I'm going to do is I'm going to say if we're going to eprint a at. This is where we're at. Else if I should do this. Let p equal 0.2. And we're going to figure out how to do a comparator in Rust. Self.position equals p. I don't know how to do this yet, but we're going to get that working. If self.control that is sum, and self.control.unwrap. I wonder if there's a clearer way to do this. Equals p eprint control room. We treat it as a wall, but it's also control room. That might screw us up later. I haven't decided yet. It's something we can change. Else we're going to print out the match of the board. So at least we'll see the at and the c and where we are first of all. And let's see if this compiles first. Okay. We have something wrong here. Oh, this is all wrong, yeah. All right. Partial equality. So how do we implement partial equality? That's what we're going to figure out. Rust implement partial equality, which is really weird because I thought equals equals would be like full equality. Lost Delta Wolf, we're programming in Rust. We're doing this coding game called Labyrinth. I can show you the graphics right away, how we move around like idiots at the moment. And actually, I can show you right now. We're going to, oh no, because it compiled it. I had to fix this first. And we're doing Rust, and we're programming moving through a labyrinth. And right now, I want to figure out how I implement partial equality in Rust. So it's something new. It's part of the point. No, that's not what I want. Derive. No, I just want partial equality. How to implement partial equality, partial equality. Let's see if it has an example. Public trait partial equality. How do I implement partial equality? That looks good. Let's copy their example. So if you just wait for the game for a second, you can see that we actually do fun stuff. Well, that's what we consider fun. 0.2. So we're going to implement partial equality for 0.2. Equals self and other 0.2. Bool. We say self.0 equals other.0 and self.1 equals other.1. That should implement it for us. That's straightforward enough. Okay, state.position 183. No. Point x comma y. And I think I screwed up the state. We didn't want to make this an option anymore. So our start, we always know the start. We just don't know the control room. Did you mean 0.2? Let's go to 183. Yes, I did. 128. Start is none. Now we have to do 0.2 default again. We don't use these values, but we don't know what else to set them to here. Lots of warnings. We're going to ignore them for now because we're not far enough in yet to care about the warnings. And let's see. He's going to run into a wall. We have a straight line. We're trying to check our output's correct, so we run into a wall. But the key is our output correct? Well, I hope we're good at it. We've done well so far. Lost Delta Wealth. We're doing well in the other contest. We're taking a break from the competition to do a practice one again. And this one is going to be a good practice of something we did in Tron. The Tron one was A* and flood filling, and this is going to be the same type of algorithms. And so right now we're confirming our output here. Okay, our at's in the wrong place here. That's a bit disturbing. Okay. So we're probably transposed as well. And that might explain why Kirk is in the wrong spots. Why Kirk is moving down and not across like the other stuff. Alright, so we've got something transposed. Let's figure out what's transposed here. And this is one of the ones I really hate about matrices, and a lot of people do this, is they decide to write rows times columns. And it's like, yeah, but most of the times we like to express x times y. And so this is actually wrong. We actually have columns come rows for the map, and that would screw everything else up. And it's the same thing here with KC, KR. Points are in X, Y. Oh, Avarice, you make me sad. Oh, it's not that bad. It's wonderful. It's so clear. And you want to look at like this monospace stuff the whole day in your life? Yucky fonts. I have nice fonts. Alright, so this is good. We're tracking our idiotic move to the right. And we could solve this one in a basic way, but we don't want to. We're going to jump right to the correct solution because it's going to be simpler to do the correct solution. And the correct solution is going to be... No, I'm going to convert you, Evers. It's not just for me. You have to be converted. I'm not going to be satisfied until you say you're using a serifed, non-monospace font for your development. Or you can put nice emoji in it. That's one of the nice things about nice fonts. So, you know, are there any spaceship emoji? I just checked this first. Spaceship emoji. Rocket. Let's do rocket instead. We have a rocket in here. I'm going to stick a rocket in here somewhere. I don't know why. Let's put a rocket in the debug output. And let's see what Rust has to think about our rocket. There's our rocket ship. Yeah, Lost Delta Wolf, we're actually on one of the harder contests now. I think it's actually level hard. Some of the ones on this site are actually quite difficult. Now, let's see what it shows us for our rocket. So you notice over here we have a nice looking rocket in our code. You know, nice looking rockets. And look at this. See? This is the problem with monospace. You don't even get a rocket. Yeah, this is broken. So there, I'm keeping my nice font. I want my rocket ships. And programming ligatures. Well, what, you use like a monospace font with ligatures on it? That's like even weirder. You mean like if you type a dash greater than, it combines into an arrow? I've been actually thinking of doing that for Leaf. So Leaf, I was going to do all the Unicode characters because I love them. I'm going to force people to use... Yeah, see, because you're not really using monospace either then. You're using monospace plus Unicode, getting stuff around. Okay, but this is... Well, Crossbow, I've got this output emoji here, and I don't want to output a variable name with emoji because then I can never type it, right? I can't type rocket ship. I can type all of the German characters, so we can type like A or stuff, or I can type a Euro symbol. No, Winter Squirrel, it's really not. It's not worth programming if you can't have emoji. That's why I'm so upset that when I output my debug here, that I don't get a rocket ship. I'm very upset with that. I should clearly be able to get a rocket ship, but I don't. And so their console is broken, and because I have a rocket ship here, but I'm going to have to remove it. So Elon's going to have to wait another day to ride with our program through the maze. Where was I? Yeah, we were about to actually solve this problem. And so what we have to do, and this is actually the hard part now, is I'm going to clean up a little bit first. I'm going to do a read state, or a read board, just to clear this up. I like clearing the code up. I don't like it having stuck all over the place. So we do this in the loop, read state. And I'm going to replace all the state with self, not with capital self. I think that's it. Self.board, self.board, self.start, self.control. So we have all of that. That's read board. So down here we can do state.readboard. I'd like to get this stuck in there as well, and I think it'd be more fun. We'll say read new. Actually, let's copy this first. I always do this with my code because I find it makes it a lot clearer to read when we're bouncing about. Read new, and this becomes a state as well. It comes up so fast, those stupid pop-up things, and we already set the timeout a bit lower. What do I want to do? Okay. And then we're going to do state new, C and R. Input line, parse, 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 parse. That should be good. We can leave the comments. We don't actually use this number around, so let's just comment this out. So now we have a much better one here. Very simplified. So now the main's much smaller. When I do the interview questions of people, like when I write the simple game, I encourage them to take this type of approach, very high level. You should be able to read your code without looking at the comments, and this type of setup does this. We do a read new. Okay, we get a new state, fine. You might want to put read standard in, but we're doing so many of them, it's clear here. Then we read a board, we dump it, and we print what we're doing. This is very clear. I mean, we don't have comments for it. The comments here we can ignore. They're just ones that Coding Game gave us. But now we actually have to start doing our first flood fill. And the flood fill code we can also copy from Tron because we're doing very similar. But let's actually just do it again. Let me check what it is first, and let me check how complicated it was in the Tron, whether it's worthwhile to copy it again. We're going to come back to Tron at 1.2. Get near a lot of weird stuff in here. Block board, don't need that. Score cell, don't need that. Fill. Fill is the one we need to look at. Wow. Alright, we're going to copy fill and clean out the bits. Fill is the basics for a flood fill. Now you may be asking, why do we need a flood fill? Because what we're going to do is for every one of our positions, the breadth first search is basically, we're not going to do a breadth first search like they suggest, to be honest, because that would be ridiculous. What we're going to do is every time we're at a current place, until we found the control point, we're going to find the closest unknown point and navigate towards there. And to find the closest unknown point, we're just going to fan out from where we are and add up the values. And the first control point first empty point we find, we'll do that. And so we don't even need to mark the board. That's actually a good point. We don't even need to mark the board. Actually, we do. Otherwise, the flood fill doesn't work. Just ignore me for a second. All right, so where's our board? We have a clone. Did our matrix have a clone? We have a clone in the matrix. That's very important. Cell type, board matrix. Now we have all these cells here. Let's start putting it right here. All directions. Now we have this fill. And the fill has a board. I'm going to simplify this. It has a board. And this is going to have to be a copy of the board. It's a mutable matrix. That's why it has to be a copy. And we had a distance board in the other one. Do we need that here? Yes, we do. We need a distance board as well. It kind of screws it up that we need a distance board as well. And we have heads. In this case, we only need one head. We're only dealing with a single person in this example. So we only need to say from where are we going to? Head. We might add a point of interest later, but that's something different. And so this fill might actually become not a fill, but a find empty. And actually, let's do it directly. We're going to do a find empty, but don't make a mistake. This is a flood fill. We're just going to abort early. As soon as we find the empty one, we're just going to stop looking. So we have a distance. We don't have a player. We have an open point. We have a vec-deck. That's what I'm going to copy from over there as well. We have to import the vec-deck stuff. And actually, I'm going to copy the whole top because we're going to actually put all those things back in at some point. Standard I/O. We're not going to put rand. We can't use rand. We're going to eliminate dead code. We're going to use the environment at some point as well. We'll leave it until we actually use it though. And what we call it, find empty. So what find empty does is, no, don't do that. Stupid visual code. I hate code that does this formatting. This is absolutely awful formatting. It screws up your CVS stuff. Just this is sufficient. Please do not add extra spaces, and I can't even get rid of it in Visual Code. Man, we gotta find a way to get rid of that. That's awful formatting, and I hate things that do it. It just messes up stuff. Comment. JS.comment. JS.completion enabled. Just no. Let's just fix that. False. I hope that fixes it because it's really not effective. Because when you come into a file, I know a lot of people say like, hey, this is great, it looks nice and stuff, and it's doing it again. But when you have to type in these files, it just becomes a headache to maintain. And I don't know how to turn this off. This is actually enough of a point that I will not use Visual Code for my own projects unless there's a way to turn this off. Because that annoys me to no end that it does that. And apparently this is not enough to turn it off. So there's no way to get rid of it. I want to find this first, Visual Studio Code. And this would explain why so many projects have that bad standard. Turn off code duck stars, I don't know. Turn off code doc asterisk. There we go. That's what I want. It's a popular question. Text editor sheet. That's pretty bad. Generate XML doc. You have to. Blah. I don't know why editors do this. So they've basically screwed up. Visual Code is screwed up by not providing a way to turn off automatic formatting. And in my opinion, that makes it just awful. Now, there must be something here somewhere. In the IDE, go to Tools, Export Settings. Then Export, select an environment, setting Tools, X editor, save a new file. Edit your yeah, this one might be Visual Studio Code. So I need Visual Studio Code. You're correct. Just turn off the damn stars. I don't want that. It's annoying me. Alright, I have another solution for this right now. Let's see if it works. If I just have 1 star, is it still going to piss me off? No, okay, so 1 star it accepts. So it's really just the autodoc it screws up. And as I said, that's a stupid formatting standard, and I don't like it on projects. It makes the source control harder. It screws up, especially if you're using tabs, it screws it up, forces it in space, gets all the alignment wrong, harder to maintain. If you have text in there, you can't copy it. It's just a crappy standard. Please don't do that. Please don't align your comments with stars. Just no good. Closest, actually this is unknown. So there's my little rant for the day. I'll do many of them, don't worry about it. Find the closest unknown space to current position. Alright, so we make the current position at head, and we don't need to do this. We don't have invalid positions. We don't even have this anymore. We don't have multiple players. That was all from Tron. Location is head, the distance is 0, and we don't need a player. What we're going to do is flood fill out from the current position, find all the spots. We have to find the board's things. We actually probably don't need a dist board then. We can create our own version of it. So let's actually create one of those as well. Let mut dist board be equal to matrix I32 new board.width, board.height. I hope those are exposed. Well, I don't know what you... bunch of stars then, okay. Stars, stars, stars. No, don't. If you're recommending putting stars headers as well, then I'm not going to accept that either. So what are we going to fill this board with? We're going to fill this board with -1. I don't remember why we did that. Okay, then we have boards. So as long as we have something open on the front, we get the current board. If the current distance... what did we fill with originally? I gotta see how I call this in Tron. Max. We filled it with max. That's correct. I32... what's it called? Max. Max. Standard I32 max. Max. So... current distance is get the board. So that is, if we're going to a current location, what is our current distance to there? If the current distance is greater than the current one, opt-out distance, then we continue. It means, basically, if we get to any position and we've already been there, or if the distance is, we just skip it. And so now we have a playboard set. We don't actually need the playboard. We don't need to set the playboard now. This was scoring in Tron. So our board actually doesn't need to be mutable. And we don't need a dist board. So this is a much cleaner function than the one in Tron, but it's also doing something a lot simpler. And the next distance is op distance plus 1. Op log, op distance, that's fine. And in all directions, is the board free? What do we want to do there? Well, first off, let's get the value of the board there at that point. Let board value equal board.get np. Because this is a check. If board value equals cell type unknown, this is the closest one. And this is going to look really weird that this is the closest one. Then we can do return NP. That's where we want to go to. And if it's not free, so if it's a wall, we can't go there. So if BV equals cell type wall, we can't go there. So we can't walk into a wall. And if we found an unknown, that's the first. This is the closest unknown. Otherwise, the next location is this op distance. And we don't need to copy the original op. We have no copies. Next distance, next location. And if open is empty, or this is less than the previous distance, then we push it to the back. Otherwise, we push it to the front. Now, this is make sure that this vec q here, this vec deck, we push it to the back and the front. This is actually guaranteed to be in order, I think. If it's not, then we have a problem here. But otherwise, that's okay. Should we ever get to the end, this is going to have to be an option. Because if we never have any spaces left, it means we found nothing. There's nothing left empty. And so we return none here. And I actually don't like this combination of return and end return. I don't know. If I have a middle return, end return, I like having return on both because it seems weird otherwise. Let's just make sure this compiles so far. No, of course not. 99. I never really quite understood that. Swine, this is Rust. This is Rust. We're learning Rust because we don't know Rust. And it has some features that I found interesting. Interesting enough for my own language. And I'll copy them. Yeah, Winter Squirrel, my particular question there was that, and I'll just go back to that once people, is when I have a return inside the function where there's return, it feels really wrong to just do this at the end. It's like, it's not consistent. All the other places I'll deal with that, but I think this case I'm going to go that way. I feel it's better. I'll go with that. Matrix. It's getting me really annoyed here. Matrix. Okay, it got a whole bunch of errors in that same one, so let's recheck this now. Yeah, that cleared up most of them. 102, 102, we don't have heads. Pushback head. 212. Cannot find R. Oh yeah, that should be self.height, board.height. Good enough. Cannot be implemented cell type. Okay. Enums cannot be compared by default. It's really weird. I'm not clear why. Okay, so we've done nothing yet because we haven't called that function. I just wanted to make sure it compiled because I hate when I have too much to compile. And normally I would have like a test case for this now, but I don't want to get into testing it quite yet because in order to test this, we have a massive amount of setup we have to do to get the board in here and look through it. But we might create the test functions later when I screw it up. And so, and this function is going to duplicate, and this is where it's going to be really weird. Because the A* path is going to have to find a way through it as well. And what do they want to do now? We dump the state and we want to find something. I don't know how to put bookmarks here. Find unknown. So we're going to say we're going to find the next one. Let unknown equal find unknown. And this will be the state.board and the state.position. This is what we want to do. And it's going to return an optional one. And we'll just see if this works first of all. ePrintLine. Okay. That makes perfect sense, Winter Squirrel. Although I question whether you have a real enum if it contain random stuff in it. Or are these like those weird C# ones where you're going to have like a color enum? Maybe I can kind of understand it, so maybe that makes sense. You can't compare by default. Although I guess the general convention is Rust is maybe it's just they want it for consistency that structures and enums just do nothing by default. And I think it's a reasonable consistency. Instead of making special rules, well this does this and this does, it should say, look, it does nothing by default. You have to derive it if you want it to do anything. And I think that makes sense. So we're gonna show where the unknown one is, and we're just going to visually compare this first of all, and that's our quick test for that. I should have compiled it here first. Good. Okay. So scroll up. What we're looking for the output is that some point 8, 6. This seems reasonable. That's the closest one, is 8, 6, assuming this is line 6. And then 9, 6, because we're closer to it, that's the next one, then 10, 6. So we're finding the next closest unknown. And now we have to implement the A*. From where are we now to get to that unknown? And then we can map through the whole thing and see where we're at. Okay, and how do we do that? What we want to do is it's going to look like this find unknown structure. And what we want to do is a similar function. We want to find a path. Actually, this is actually a bit incorrect. Direction 2, and we're going to give it a board. And because we're not doing optimization, we're not doing speed, we can make this super inefficient. We can just allocate stuff like idiots. Direction 2, I'm going to say 2.2 from point 2. Maybe it's better this way, from... No, because we said 2 first, from point 2. I never get... And this is going to return a direction. And this may seem a bit weird, but the idea is we don't actually have to find the full path. Now, sometimes with A* and some algorithms and some games, what you actually need to do is you actually need to find multiple paths at once. But since we're having an iterative process, anytime you have an iterative process, it makes it simpler because all you have to say is, well, where am I now? And where do I have to go? I only have to make one move. I can move in one of 4 directions. And how do I get there? And this is going to be a fill. And this is where it's a bit weird. We're going to fill it all the way up to the player. And we're going to have to modify this. So we're going to do fill. What does fill do? Find unknown. Alright, so find unknown is going to have to be modified. This one, in terms of programming languages, the list is a bit long. I wanted to say fluent. Obviously, I don't know Rust yet. I don't consider this knowing the language. I know very little about it. I've done full projects in C. I've done full projects in C++, and I still actively do C++ coding. I've done full projects in Java. I don't do that anymore. I've done large projects in Python, as large as Python projects can get. I only maintain some test suites in that now. I do C#, actually, Uno variant we have at work. I kind of know C# well enough, and JavaScript, I kind of know JavaScript, I guess ES5 or ES6, whatever it's called. Not a lot to know there. And what else do I know? I used to do some Bash, but I've given up on Bash. I don't use Bash anymore. I've replaced all my Bash coding with Python coding. I think that covers the language. There's probably more language than I know. I've done some Node.js as well. And I can pick up this one now. We're picking up Rust now. Obviously, I know... Actually, I don't know my own language, Leaf, yet. I still have to look things up whenever I use it, because I'm still debugging it. I find it's very good to know a lot of languages, so when I come into a project, I'm not biased by what I know. There's a lot of different patterns in all these languages, and that's what's really interesting about them, all these different patterns that you see. And I've never actually used languages like... it's called Leaf, and let me type that in here again, right? Say leaflang.org. I'm working on it now, the compiler. I've spent most of the day actually adding error messages. And this is one of the reasons why I'm looking at Rust, is because Rust has a few features in it which I think will make it into my language, and I think it's worthwhile to learn them and learn these new features, in particular the weird borrowing system. You'll know, if you watch this show enough, you'll understand their borrowing system. I scream at it a lot. It really annoys me, and they're solving a particular feature with it. The thing I really like is their matching system. I don't have an example in this code. This is the basic match here. Yeah, Winter Squirrel, I'm very sorry about that. Is it really Chrome? They're said in June. They said they wouldn't convert it to June. My provider doesn't have SSL yet. It's a completely passive website, and I thought Chrome was going to convert to June. And I've talked to my provider now, and I told my provider I need the HTTPS. I don't maintain the site my own. I mean, I upload the files and stuff, and we'll have to get HTTPS there because it's definitely a problem that it's not HTTPS, and that's what your warning is. But it's a 100% passive website, so there's no forums, there's no entry or anything. And Chrome was supposed to give people until June before they gave the warning. So hopefully you can still see the site. It's really weird you can't go to it. You should be able to definitely go to it. I mean, I mean, I don't know why you wouldn't be able to go to it. My Chrome, I have Chrome too. leaflang.org. I don't know why you're getting warnings. Like I say, Chrome is supposed to give a warning only in June. There is only a non-HTTPS version. There is no HTTPS yet. Right? If you go to HTTPS, that's not implemented yet. That's weird. They're supposed to give us half a year to do that still. Okay, go to HTTP. Maybe it adds HTTPS by default now. So here's the other one. Maybe it's just the default now. So that could possibly be it if you just type the default. Okay, so that's probably what's happened is, sorry about that, I never realized that, because when I type leaflang, I just assume that it goes to HTTP, but it must be going to the SSL version now. And I don't have SSL support yet. That has to come this year, though, because Chrome is going to start issuing those warnings as of June. It'll still go to the site, but it's going to say the site is not secure because it's not using HTTPS. And I kind of agree with that. I think everybody should use HTTPS now for everything. It's just, you know, my provider doesn't provide it yet. And I have so many sites, I don't have time to move them all around. And I hope they'll do it soon enough. And I won't have to worry about it. But there's a site, that's the language. There's only so much features, only so much documented there. There are some examples. And if you want to help out or take a look at it, just follow me on Twitter and ask me questions. I'm more than happy to help talk about it and help you get it running and stuff. Right. Now, back to the Labyrinth. I've gotten lost in my own Labyrinth. Winter Squirrel, it also works on OS X. And if you follow me on Twitter or send me a message, I can actually produce a packaged version. It's something I worked on. I have a distribution. I just need to upload it. And I can give you a packaged version for either Linux or OS X. I don't have Windows yet. And Windows is actually, it's going to be a lot of work to do. And I have to focus elsewhere first. So it's going to be Linux and OS X. The reason I did OS X is because it really wasn't much work to migrate from Linux to OS X. It's the same basic thing. And I also want to do mobile for it. Well, we'll have to see. There's enough pusher for Windows, but I really have to focus on the language. I need to get it working before I start spreading out. Because if I spread out too much, I don't have nothing working. Yeah, IKFS, just try it. Start with small compilers. Small compilers, like, just make little languages. They're okay to do. Full languages are rather complicated. I'm not just saying that because, you know, I want to pump up my language, but there's a lot of features in a language that are very, very hard to get into. Like the borrowing in Rust and stuff, the closures from other languages. There's a lot of high-level stuff, but really all you have to do is just start programming one and start adding stuff and throw away the whole thing and start again. And then throw away the whole thing and start again. This is probably the 4th or 5th language I've programmed, and this is the first one I consider a full language. And it's lots of fun. I'm having a good time. And I was adding error messages today. You can see it in the background here somewhere. What did I have? The last thing I did. This is all in C++. This is the operator I have. The Dragon Book. Ooh, I don't know the Dragon Book. So this is what I was doing today in Leaf. I was adding nice error messages because before I would add crap. So this is a nice error message. It says you have an invalid operator in the file. Okay. And all right, before I get lost further in the maze, what was I doing? Where was I? Control Z. It was my favorite way to get back to where I was. Direction 2. Yeah, we have to modify find to be a fill. So fill has to fill, and at first time it finds. Let's put an option. We're going to make a fill function. Fn fill. Yeah, the start to finish is very good to do. They say getting something running is the key point to compilers. You really want to just have the full from front end to back end first before you really start getting deep into it. Alright, so we're going to do a fill, and I'm going to break this up into two functions now. Board matrix. We're going to fill from this point. And we're going to give an option here, and I'll tell you why in a second. So find unknown is now going to create its own board. And so it's going to do fill board head. And we have to pass the dist board in now. Dist board will be a matrix 32. I guess don't be afraid of it. There's a lot of stuff to do in compilers, but just take something simple. Just try to do something. Start with a virtual machine. They're easier than a compiler. Or an interpreter, I should say. Interpreter. And you just have to get into it. You definitely don't need a degree to do them, but obviously the more exposure you have to programming, the better. So now what I've done is change find unknown to call fill. And yeah, parsing expressions is hard. Do a stack-based calculator first. Stack-based is far easier. If you're looking for that, in Leaf, I'm using the shunting algorithm. You can look up the shunting algorithm or the shunting yard algorithm, the shunting yard. If you want to parse expressions, the shunting yard algorithm. This is a good starting point for parsing algorithms. I mean, expressions. The Leaf expression parser is actually based on that with a heavy modification. I don't follow the original one. I have a lot of changes to it. But that's a good place to get started with parsing expressions if you want to parse on your own, which I recommend. It's a good experience. Okay, so I have find unknown, and it's going to take fill board. It wants to find it's looking for something. Fill can also find an exit point. Now what I'd really like to do is have a callback here, and I keep forgetting how to do that in, what do I want? I want to do a lambda. I'll just put another point. Find option cell type. We're looking for a particular find. If we find it, we'll return it. Otherwise, return none. So down here, we're going to say if find.isSum and bv equals find.unwrap. Then we'll return some np. That says, and so this is basically find unknown is now split. We pass the board in, and the fill will find until it finds the empty one, and the dist board won't be completely filled. But what this lets us do is we can use the exact same algorithm here in direction 2. We're going to fill the board from this point to the distance board, and we're not looking for anything. So we're just going to say none here. We're not looking for anything at all. And we don't care what the result is. We just ignore the result. I hope we can just ignore it, because we're not looking for anything. But now our board is filled. This is the basic. Okay, this is not A star. This is kind of a cheaper A. This is a really expensive A star. I'll show you how we fix this later. The moment we hit the 2 point, this 2 point, we should stop. But for now, we're just going to fill the whole board. It's simpler this way, okay? It's just a lot simpler this way. Now we have this dist board which is filled, and we're going to look all around ourselves for and D and all there. So we're going to say all around the cursor position, because we filled it from the from point. I mean 2 point, sorry. Good thing I said that. This is where we want to go to. What will happen is that where our current position is now, all the numbers beside us will be the lowest number closest to that 2 points. And I'm wondering if I can show this really quickly somehow. Oh, without drawing a graph, this gets really hard. Do I have a... Let me open up a spreadsheet, and I can show you what I mean a bit. I have encountered lifetimes, and they're annoying, but I do actually know... I have an example of how to use them now. Okay. So let me explain this filling so far. If we have a filling, and say we start filling at this point, this is our fill algorithm. We start filling it here. What the algorithm does is it goes to each spot beside it and says, is this open? Then I'm going to stick a 1 here because that's the next distance. And writing my own traits, not really quite yet, but okay. And so the fill then says from this point, well, this one's a 2, this one's a 2, this one's a 2. And then it goes through all the other ones first and adds in 2 forms. So this is how flood filling works. But let's say we have a wall here. Let's put the wall down here. We can't fill in that area. So this one fills to 3. And then it's going to end up filling 4 around here. And what we have, if we have the target location here, this will be 4, this will be 4, and this will be 5, and this will be 5. As soon as we hit the target, and this is what direction 2 is going to do, we have the target, and it's going to look for the closest value around it. And so this is going to be 6 on this side, and this is 7, and this is going to be 6, and this is 7. And it's going to pick one of these locations, so it's going to say, well, one of these values, these 5s and 7s, has the lowest possible value. And it's just going to pick the one with the lowest value because that's the closest to the destination. Because this is the destination here, 2 equals that. And this was from here. And from we pick the one of the 5s, and that'll move us straight towards that destination. And this is A star, but it's a simplified A star because we don't have a heuristic, and we just generally don't care because I don't have any speed consideration whatsoever. I'm just doing a flood fill. I'll fill the whole board up, and A star, what A star does is it actually starts pruning the paths it checks. It says, well, I don't have to fill everything. I can check. I can say, well, I'm not going to go further away. So it gives up on ones past here because it says, look, you're further away from here. Why you bother checking that? It's not guaranteed that A star is faster, though, because A star has a priority queue, and priority queues can be slow. My algorithm has no priority queue. It can flood fill this thing extremely fast. And I've used this a lot. And so some cases, flood filling is faster than A star, especially when you're on a grid. If you do not have a grid, or you have movements that have different costs, then it's a lot different. But we get away with this now. So I hope you understand basically what I'm doing here with this. And so now I'm going to do this. I have to find the minimum distances here. And let mut_min equal standard I32 max. And let's mut. And there's going to have to always be one free, otherwise our board's screwed up. So I'm not going to worry about the case where we don't have one. And the direction equals direction. It doesn't matter what the first one is left. So the value at the board is we have diskboard.get. What do we have? We have from.add. No, I have it. Microbic music. Microbic music. Okay. Get these. I can't pronounce them right. It's excellent. I love it. I love working on compilers. If you have any unique features, please let me know, and we'll try it out. They are a lot of work, so it's good on you for doing that. That's really awesome. It's a lot of effort to stick with it, and there's a lot of interesting problems in compilers. There's so depth. There's so many layers behind them, and I picked mine up because it's so challenging. I am using LLVM, so my final backend is LLVM. I actually have an intermediate language, though. The reason why I'm using LLVM is because I have enough work already. I don't want to deal with machine specifics. My language focuses primarily on the high-level stuff. And so I actually compile down to my own IR, and then I translate the IR into LLVM IR. And that last little LLVM adds a huge amount. I actually need to have the full set of optimizations and everything, exactly what WinterScroll says. The optimizations are great. It's really awesome when I write like a Leaf program. I have like these, I have like a 50-line program that's doing a test, and I turn on optimizations, and then I get a simple 5 as an answer. Like LLVM can remove entire functions, and that's what I love about it. Its optimizations are really great. And I can't interpret my IL yet, but LLVM also has a mode to compile in memory. So I have a mode on Leaf, and if you've watched my Leaf shows, you can just run a source code directly, and this is all compiled in memory. So there's no reason to interpret it yet. I have yet to have a reason for doing interpretation. If I do, I will do it. It should be a very simple machine, but as long as L of M does it for me, I see no reason to. And there's not a lot about Leaf, but I did algorithm. My algorithm videos are actually using Leaf. And what now is I'm on this race right now. Yeah, I put everything on YouTube. I'm in this race right now to get Leaf to a point where I can do visualization, because the videos are kind of boring without. But I'm going to do more of them, and I'm going to show more of them. And the last complaint I had was the error messages suck, so now I'm working on error messages. But if you check out my YouTube channel, you can look up the ones for algorithms. I think there's only a couple up there right now. I haven't done so many, but there are some there. And it'll show you a bit of Leaf. And I explain complexity and stuff there too. So if anybody wants complexity theory and stuff too, check those out. The last one I did was a basic binary tree, and I meant to complete that last week, but I just ran out of time. Alright, where am I? I gotta get to step. Oh, so OP locked at steps. So from.step. Step is a function on a point that steps in a direction. And that gets us the direction there. And YouTube. Yeah. Do you want to see the YouTube channel? I can just search for it. It's down there. Where's it down where? Oh, it's probably on my page. Yeah, just look at the Twitch page. You can see it before I have to go look for it. Okay, and so we can say if v is less than min, then min equals v and direction equals d. Good. Wow, okay. So just go to YouTube. There you go, yeah. With the wonderful YouTube naming convention, or you just search for mort-ora-y, and there you have it. You wait for searching. The first thing that comes up is building a Christmas tree. This is what I do at work. I don't build Christmas trees, but that's the other programming system we have at work. That's the animations and videos. And in my videos, the last one I did with Leaf was, wow, I've done quite a few in between. There's writing a binary tree. That's the one down there, writing a binary tree. What is big O? What is time complexity? I did a binary search, and some older ones, vector programming. And there might be a few older ones, linked lists. So there are a few on there. Look for the ones that say Leaf. And all the other ones, I also do the ones for work. I do animations there. And today I'm doing a Labyrinth. Alright, so we have direction 2. I think this works. What direction 2 does, it says what direction I have to move. And yeah, enjoy them. What direction I have to move. And it uses the same flood filling again. It just finds the one closest to the player. And does a direction 2. And this is what we have to do down here. Let d equal direction 2. And we want to find the closest unknown one. State.board unknown. And then we're going to move that direction. And do we have an emit direction? Any emit function? We don't. I'm going to copy one from Tron. We must have an emit function here somewhere. Emit direction. Yeah. Once you've done one coding game one, you have a whole bunch of them defined, because they all like to use... They're all games, so they all use this grid-like thing. Very few use non-grids. Emit direction, that should be fine. Actually, I don't like emit. To me, that's wrong. Where'd it go? Get dir... Or no. Actually, no, that's fine. Emit direction. There's a print line. Emit direction D. So let's see what errors we get. Not so many. That's good. 165. D is... Oh, that's direction. Got an error there. Expected 4 parameters in 105. Fill board, destination board. And yes, we wanted some cell type unknown. We're looking for unknown. What do we have next? 284. Direction 2. Oh yeah, from state.position to this position from where we are now. What do we have? No. Alright, if we don't have an unknown, then we'll have to do our endgame. We're just going to let it crash for now. Actually, no. Say if I should do it this way. Let's do it the rusty way. match find unknown to some unknown. Otherwise, we're just going to say print line not yet instead. I don't actually know if it needs comments here. I'm going to put it. Are you interested in compiler coding? If you're interested in compiler coding, I can gladly start streaming it. It will be during the days. I was thinking of doing it with the standard library. I'm at the point where I'm building a standard library, and I can start doing that. But if you look at the other algorithms videos, you can notice that those are probably standard libraries as well. And if you guys do find them interesting, I could do more. A lot of the compiler stuff, the deep compiler stuff, maybe I can fix some bugs, but a lot of it I'm really deep in my head with, but definitely the standard library. And like I say, the error stuff I was doing today, I could have done. If people are interested, I can definitely do it. I'll be a bit less formal than this, but if I don't mind doing it, and it might give me more incentive to do the progress. Okay, what did I do wrong here? Yeah. All right. Leaderboard 108. That's right. This has to be a mut matrix. And this has to be a reference. Fill and mut. Oh, well, compiled. Let's see if we do something. Let's see if this visuals, if we actually do something. I don't know what I did. Oh, index out of bounds. I did something wrong. Okay, so we return to max here somewhere. And that's the max we stuck in there. And at 45, line 45 is cells coming from 131. Not there. Get NP. Alright, so we have to actually do this if board is valid. If it's not valid, continue. It'd probably be on the weekends. So Friday evenings and Saturdays are generally when I do Leaf. And if you're in like an American time zone, probably not. I tend to need to be a lot fresher, you know, brain-wise to do working on the compiler. I'm not to say that I'm not fresh to do this, but these algorithms, I've done like these algorithms so many times, this basic one, that I can kind of talk and do them at the same time. Well, see, I'll try some Leaf ones, and they'll be on YouTube anyways, but you won't have the back and forth to explain it. Canadian Eastern Standard Time, okay, yeah, that's... Unless you catch me Saturday morning, because sometimes I get up really early and work on them, so maybe I can do that. Next time I'm up early, I can stream it, and if you catch me online, then great. I'm not here next week, though, so I'm going to take a vacation. Board is valid and P. I think that's what I wanted. Continue. Oh, I put the wrong continue, not continue. Okay, and I think I screwed up the thing. I went out of bounds here. JVM languages, I don't know. LLVM runs just fine on Android as well. You can, and I intend on doing that. I was hoping to do it this year. I have so many things I want to do, but I wanted to get Leaf running on Android. The problem with using a non-JVM backend is that it's extremely hard to interface with the actual SDKs. So unless you want to write a library to do that, it's really hard. Alright, what do we do? It looked like we moved. He's not moving through a maze, and I actually, but not yet. So I recognize not yet. I recognize I was at the point where there's nothing left to do. So let's look at the video for one of these. Let's take a video of this one, and let's actually look at what happens. So we're doing some exploring. So our basic exploring works up till there. Yeah, because there's no more unknowns. So this is the point where we fail. We hit here because we found the control. That's fine. And so now we should be done. Windows goes in Kotlin. Yeah, I have another friend. He does payment systems over in Chicago. He has a really nice system there, and he's been doing a lot of Android. All the stuff's written in Android, and he really likes Kotlin too. I mean, compared to Java, it's really nice. Java's like really low on my list of languages that are like friendly. It's just not. It just I don't like Java. I did Java a long time. It's kind of like that necessity, and some things have it, but I don't really like it. All right, so we're at this end now. This not yet is pretty clear. We better know where. Actually, I'll just comment this out. We might need. We can stick it back in. We better know where the control system is now. And when we parsed it, we said self.control. So we're going to eprint line. Where is that control point? Eprint line. How did I print that? State dot control. Okay. All right, I'm going to take one short break. And I'll be right back in half a second. All right, I'm back, and just gonna keep shrink. Let's see you guys cut up. Yeah, there are a lot of JVM languages. I think Scala was another one. I didn't much look at that one too, but there's several of them. Just take a look. I don't know if LLVM has a JVM backend. I wonder if it does. I don't know. So many new languages. Dart, I haven't heard a lot of nice things about Dart, but maybe. I know Swift. I mean, Kotlin's better than Java, but it's not a huge step up. It's just like people saying Swift is really nice, but that's compared to Objective-C, and their Objective-C libraries are just garbage. So, I mean, it's really hard to use, and it's so outdated. So Swift is easy to get better than Objective-C. Maybe they're good. People say nice things about Swift and Kotlin, so it's got to be good. So inline printing control. So what we have is now, okay, once we've explored the map, and this is what happens right here, we've explored the map. So let's trigger a state change. The moment we figure a state change, Kotlin has an LLVM. Now I'm really curious on how that works because of the garbage collection. LLVM, I mean, there's no garbage collection in there, so it must have a runtime model. So even if you do compile and you must still have something doing garbage collection, and I don't know how that works. That'd be very interesting to look at some point. And I'll have to look at it sometime. I'm going to finish my Labyrinth right now, but definitely I'll take a look at that. As I said, this is part of the reason why I'm doing Rust, is I'm exploring these languages. Not that I intend doing all these again with Kotlin, but if there's interesting ones, we'll definitely do it. I've lost track of what I was looking for. State. Where's my state? Okay. So the state has now 3 states. Let's do phase. And this has to have a partial equality. Derive partial equality. And we're going to have a state called scan, control, and exit. These are the 3 states we have. Yeah, everybody should have their own language. It's good and it's bad for everybody to have their own languages. The problem with so many languages is that they're all lacking features. Right? You'll never come close to C++ a set of features. It's a very mature language, but it has a horrible syntax. You can understand black. All right, so we'll build you a giant shrine in the moon for that, Zygliv. I think, if that's the reference, correct, or. And everyone should have their own language with blackjack and monads. Yes, let's go for that. They're good to explore. And I don't mind it so much because I think domain-specific languages are good. I'm very much in favor of domain-specific languages, but I think we should still have some very strong general-purpose languages, because there's a lot of things you just don't want to do without a full feature set. Like I use C# at work, or our version of it, and even looking at there's so much stuff you can't do compared to C++. And I write the Leaf compiler in C++ itself, and I keep looking and going like, it's going to be a long time before I get Leaf here, and there's just so many nice features in it. It's just too bad the language is just so much syntax. It's like, blah. I don't even know if Rust runs in Android. I'm sure it works. Just pick a language. Pick any one and use it. Okay, so this phase, my state's going to have a phase. And it's a phase. And the phase is like, what am I doing now? And there's a scanning phase. That's where we start. This is mean we're just looking around the whole maze. We're finding everything. And this is what it recommends. We just keep scanning until we've exposed everything. And then what we do is so we're actually going to do it here, match state.phase. It's going to be a bit tricky doing the first phase. So we're going to put the phases up here, fn step scan. Java is an okay language. That depends what you're doing. If you're doing machine learning, please do not use Java. I had to teach a guy with that, and it's like the syntax is so huge. If it's a small project, Python works, but it's untyped. But Python seems to be good for machine learning and data analysis. If you're doing just small sample projects, it's not. I mean, it could be fast enough too, because they mainly use libraries. It's like a glue language for the libraries, but I know very little about it. Yeah, learning new languages can be rough. If you learn enough of them, though, it's fast. But since you're still in school, I'm guessing you haven't learned a whole bunch of them yet. I say a lot of the stuff in Rust here, we can pick up a lot of the stuff quite fast, only because there's virtually no new concepts in Rust to me. The borrowing one is, and yeah, that's the advantage of the JVMs. You can mix languages together too. Alright, so we're going to put this up here. Step scan, it says find unknown. And we're going to do a step. Do a match self.phase. Probably don't need scan. Using phase star, or use phase star. Scan is going to go to scan self.step scan. And control, we're looking for self.step control. could use Python's not a bad language for a lot of school projects. Depends on the project. If you need to do an Android thing, I don't think there's any... I haven't heard anybody doing Android or iOS development in Python. That might be your only limitation to it. Self.step-exit. Because this is what we do in all these cases. We exit, we step. So the game now just becomes a matter of state.step. Get rid of this. If we ever don't find an unknown one, then what we do is we self.phase equals phase control. So the moment we run out of things to find, we're going to go to control, we're going to do self.step control. And step control and mut-self. There's nothing wrong with that, I guess. Just why not? You never go long learning a language unless it's one of the old ones. Like learning Objective-C now is probably not so great. Learning like really old languages is not so great. But learning any of the new ones, there's always things to learn. There's always purposes to any of them. And it'll make you better out when eventually all of them are replaced with my wonderful Leaf. You'll need all those concepts because it's all going to be in there someday when, you know, I just get enough time to do it, when I stop playing around with Rust and working on Leaf. Okay, so step control, what we have to do is we have to find our location to unknown. We want to say let D equals direction to state.board, not unknown. We want state.control.unwrap. Yes, Winter Squirrel, that's a valid point. Programming is not just about coding. Programming has a lot of disciplines to it, including that politics aspect, and that's why I do this stuff. This Rust coding is just coding. Of course, we have competitions here too, so state.position. We have to know what... Actually, if we're ever at the current position, so a step control, if state.position equals state.control.unwrap, else, go here, then our phase goes up. So the moment we hit the control thing, we say self.phase equals phase exit, and we do self.step exit. Direction 2 and direction to state control, so we emit direction D. Okay, and step exit is almost the exact same. Let D equal direction 2 on the state.board. State.start, because this is where we're going to start, is actually going to the exit, the state.position. Emit direction D. I think if this works, the logic is complete. We're just missing something. Derive 202. I forgot the syntax. What is the syntax for that? Hash derive. I got it. Okay. Got a bunch of stuff. State.board. 287. This is now self.board. That's correct. Self.position, self.phase. Good. 287. I really wish I could have the double clicking here enabled so we could somehow go to the lines, but it still doesn't have that set up yet. It doesn't understand that yet. I don't know how. I tried it once, but I couldn't get it figured out. Self.position. 302. Self.position equals self.control. Then we go to the next phase. Otherwise, we look for how to get the control. Self.board, self.control, self.position. All these are self, 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 self. No, do not do C++ on a device. You can avoid it. And Avarice, you mean me? itself. Okay, so we got this. I think if my logic is correct, we might actually solve one. So let's try the first one. And I can't make that bigger without going full screen. Let's see if he actually goes through the maze. He goes through the maze and he gets back to the exit. So we won the first one. So I'm going to go full screen and see if we survive all of them. So remember, the first bit, he's just looking around until we find the control point and we're done exiting. And some of these exit briefly sometimes. I don't know why. Like, we exit too fast, like the game doesn't catch up. I don't know whether we're dying or whether what's happening here. I don't know what's happening, if we're dying or not. Because I can't tell on the full screen. Or whether it's just so far behind in the lag. This is the last one, so we might see the whole thing. So you know how he's looking around. I think the other ones are just dying on lag, not because we made the wrong move. So we keep looking around. And then we find the spot to the first one we don't know. Alright, find all those. Probably didn't actually need to go there. But that's okay. We already knew it was an unknown, so we're going to go down here. And we just track all the unknown stuff. Then we're going to go find the control point, and once we found the control point, we're just going to head back to the start in the closest possible way. So we found the control, and we just scan everything first, and then we find control, and now we go back to the start. And this little exclamation here, we should have found the shortest path. There's no way we don't have the shortest path, but they're making it really, really tight, so they must be exact, so you can't be off by even one, I suspect. Okay, so we made it in exactly 0 moves. And that means we've passed all of them, which is really good. Do we want to see another one run again, though? Because that wasn't so much fun. Let's see this one run again. So it was just falling behind before. So this is another maze. You can see kind of what he does. He follows a weird path because we're just scanning in the first phase. We're just uncovering the entire map, all the unknown stuff. And I don't know why they call this Kirk and Spock, because he doesn't look anything. And so we do weird things like this. And this is actually just the final map inverted, which makes it less interesting. And we're doing an exactly symmetrical approach. This is really unfortunate. That's just the last map inverted. Avarice. Okay, yeah. Avarice, then that's what you meant. I'm going to try and get that working at some point. Let's see us play this test case. Let's play 5. Is it any fun? Alright, so the same thing scanning. They have these little bits of empty things on the side. I think they're meant to screw you up, but our searching basically says if you can't get to it, then it just ignore them. I don't care about it if I can't get to it. And the control is treated like a wall. That's why we don't accidentally ever go into it. They should have stuck the control right in the middle once. Like the test cases would have been better if they put the control right in the middle of a path, so that if somebody accidentally walked onto it, it'd screw it up. And so now we're going all the way back to the start. This is completely unnecessary. But what we're doing is we're uncovering all the fog of war. We could actually improve this if there was an optimization that the moment we found the control, every turn, if we do an A star from the control to the start, if the shortest path doesn't touch any unknown, you could actually follow that. You don't have to explore all the unknown. But since we have all this time, we don't have to do that. We don't have to do that optimization. But if there is an optimization problem involving this, we'll actually have to do that to reduce the amount that he scans and do a proper A star on that and do it every single round. Alright, but I think that's what we have. I think we've solved it. Not much more to do. We have the code. Great. We solved it. Might as well submit it. Is there another Labyrinth one? Let's go find out. There's only a score. I think this is pretty good. This is a pretty good puzzle. Test cases aren't the best, but next step. What's my next step? Alright, and so it puts up level. It doesn't get us touched too much further. It gets us more points. Is there anything else with Labyrinth, though? I'm looking, is there an actual... Is there one with optimization with Labyrinth? No. Let's go to practice. If there's another one with Labyrinth, because it would be nice to have that one extra step. I mean, that was a hard one, I think. And I think that was it. So we're done with Labyrinth. And I think that's pretty much done for the day then. Or, that was hard. We have more pathfinding, more pathfinding. There's a lot of stuff here. That was it. That was it for Labyrinth. I think we're done with that. There's all our code. This is part of why the code is a bunch of A* and flood filling and stuff. So it's not a lot of code here. Okay, it's still it's still 300 lines. Let me check my status. Git add.commit Labyrinth solution. I'm not publishing this anywhere yet. And so that's all I really wanted to accomplish today was the one, to get one more of those in to do A*. But it's something I said for Leaf. I'll actually do it for Leaf. I want to get Leaf to start visualizing stuff. So instead of having to resort to this spreadsheet, I could actually show you graphically what these algorithms are doing. Because I think that would be really nice to understand, especially A*, flood filling, and all the pathfinding ones are really nice to visualize. What actually are they doing? Is it something reasonable? And then next time I start, I don't know when I'm going to come back again, because I'm not here this week. Most of the week I'm not here. I won't be available to actually do a stream. I'll have my Fuse stream tomorrow. If you're interested in animation, you can watch the Fuse stream or apps. I still haven't decided what I'm doing with that though either, but I'll do that. And maybe on Wednesday, I don't know when I'm actually not available. But Friday and Saturday I'm not here, but Sunday, I should be back for Sunday. I'm not sure what I'll do yet, whether we do another competition one. I think so. I think we'll do more competition. Code Golf we're done with. Optimization maybe. Or let's go back and do another bot programming. I think we'll do the Code for Life one. It's the newest one. Actually, it's an old one. We do Code for Life, and let's go back to multi-agent programming. And by then, as Everest says, if I got the RLS installed, I can actually get the building inside the tool working. That would actually speed us up a little bit. I don't think I'm that slow going up and down, but it would simply help a lot if I could do that. Alright, so I thank you very much for watching, and I wish IKFS all the best with his project in learning Java and how they do the Android thing. And to answer that question, I have no idea how I installed Rust anymore. I gotta go find out. I wanted a newer version, so it might not be the one. If it's in the package manager, I'll find out. I'll try and get that upgraded. I don't remember. And again, please follow me, subscribe, Twitter, YouTube, wherever you want. The videos are there. And don't forget to retweet me. And again, tomorrow, Wednesday, I'll do Fuse. Otherwise, it'll probably be next Sunday before I'm back with this stream. And I thank you very much for watching. And I hope you enjoyed us solving the Labyrinth. And we'll see it out. And I think I did use curl. Last message, I'm pretty sure I used curl. And we'll see how that works out then. Alright, thank you, and have a good night.